This video might look a little bit different to you guys because we're going to use the full screen so I can switch back and forth to the internet and show you some graphs. But for now we're just going to fill out this part right here. So the solution to a system of equations is represented graphically by the intersection of lines. So it could be 2 lines or 3 lines, it doesn't really matter, but it's wherever they intersect. Could be multiple times, could be once. That is the solution to a system of equations. That's when their x and their y work for both equations. So for example, we're going to reach back a couple years here and think this is the equation of a circle. X plus 5 squared plus y minus 2 squared equals 9. So that's the equation of some circle centered at -5, +2, with a radius of 3, the square root of this number. And then I have a quadratic, y equals x squared plus 2x minus 7. So we're going to use Desmos to look at this. So when I graph my circle and I graph my quadratic, I can see that they have an intersection here and here. So that allows me to talk about what my answers are. My answers are -3.7 for x and -0.7 for y. That's one solution. And then my second solution is right here at -4.6 and I'm going to go ahead and do 9.7 on this one. So two answers that I could get. Now, could I have done this longhand and solved this out? Sure, that's absolutely a possibility, but in some cases the algebra is so burdensome that the ability to have a graphing software or have a graphing calculator allows us to quickly input our graphs and then simply search using the functions on our TA for the intersection of these two. I just wanted to use this software here so it was easier to view. But remember, when you can graph fit, often that's the easiest way to determine the solution to a system of equations. I'm going to minimize this here. I'll come back to this. So we have two solutions, and we found our circle and our quadratic, and we had two answers. All right. So algebraically, how do we look at solving? There's a couple of things. You can use elimination as a method, which I like, and you can also use substitution, which is also a great method. Not substitutions, just substitution. And so whichever one works better for you is the appropriate choice. So for here, I'm going to use elimination because I wanted to. You could also use substitution here. Doesn't really matter. So I'm going to line my equations up so that I have this lined up under here. So I have 2x minus 4y equals 9. And then I'm going to reorganize my two equations. I'm going to reorganize it so all the x's are here over the top of each other and all the y's are here over the top of each other, and then I have my c term over each other. So bring this 4x over, -4x plus 4y equals 2, and 2x minus 4y equals 9. And now I have a pair of terms that match here, which means I can easily add my two equations together, which leaves us with only an x because these are going to become 0. So -2x equals, add them up, 11, x equals -11 halves. Have I finished my problem? No, because the question wasn't what was x, it was asking what's the solution to the equation, so I need a value for x and for y. So I have to come back in here and plug this into either one of the equations. It doesn't matter which one you choose. Well, I'm going to do this one. 2 times -11 over 2 minus 4y equals 9. Let's reduce. -11 minus 4y equals 9. Add it over. -4y equals 20 and y equals -5. So if I was going to graph these two linear equations, where they intersected would be at the point -5.5 or -11/2, -5. I'm going to go back to this original problem we were looking at here with the circle and the quadratic, because I did want to take a second to look and say, is this doable algebraically? Sure, it is something that we can do, but that doesn't mean that it's the friendliest method. So I'm going to use substitution here. Every time I see a y in this equation, I'm going to replace it with all of this. Okay, so x plus 5 squared plus x squared plus 2x minus 7 minus 2 squared equals 9. Yucky. This is going to be x squared plus 10x plus 25 plus x squared plus 2x minus 9 squared equals 9. Okay, so I have a polynomial here being squared, which is going to make my life kind of miserable here for a minute. I'm going to do this. We'll come back to our graphing calculator, and we're going to say x squared plus 2x minus 9 to the second, enter. And we're going to hide this and this. Oh, it's a quadratic. Yucky. I thought it would actually simplify it for us. Well, it didn't. So we're just going to come back to our presenter. I'm sorry, I made a quartic, not a quadratic. So we're going to come back in here, and we're going to do it by hand. So this quantity times itself is going to give us something big. We should have a 3 by 3, which will give us 9 terms to work with. Don't lose any of them. That's always the worst. X squared times x squared is x to the 4th plus 2x cubed minus 9x squared. Now I'm going to take my second term and multiply it all the way through, extending my distribution. 2x cubed plus 4x squared minus 18x. Oh, I'm going to run out of space here on my paper. That's okay, I'll just squish it down here. Minus 9x squared minus 18x minus 81, and this all equals 9, and it's all being added to x squared plus 10x plus 25. So now we have to combine all of our like terms and try to solve that booger. All right. It's only one x to the 4th. X to the 4th. I took care of him. Then do we have any x cubes? Sure, I have 2 plus 2 okay, 4x cubed. All right, x squared. Sure, I have a lot of those. 1 minus 9. 1 minus 9 plus 4 minus 9 negative 13. So we have negative 13x squared. So I took care of all those boogers. And then I have my x's, my x to the 1st. So I have one here. 10 plus negative 18 and another negative 18 is negative 26x, and then 25 minus 81 equals negative 56, and that all equals 9, so we're going to go ahead and move him over to the other side too, which gets us 0. So 56, negative 56, and negative 9 can be rewritten as minus 65 right there. So you could factor that out, which would be super fun, but we already know that our answers don't work out to be something friendly because we used our graphing calculator to find that. You can use our graphing calculator tool here. I don't know how well this is going to work. We'll see if I can get it to zoom in without having too much glare on it. Whoop. There we go. So I don't remember if you guys will remember this or not, but I'm going to go to algebra and then polynomial tools, and I want to find the real roots because I don't care where it exists on the imaginary plane. I want to know where it exists in the real plane. So poly tools, I'm just going to do find roots. So 4 is the highest power that we have. Enter. And now I'm just going to go through and put my coefficients in. So 1, 4, negative 13, negative 26, negative 65, and hopefully this will all work for me. Okay. Okay. And I got the wrong answer. We already know our answer is not supposed to be this. It's telling me the negative 5.8, 3.46 are our 2 roots. So I must have made a mistake there somewhere in my algebra. If you can find it, point it out to me on Monday. But this is why, point being, this is why we use a graphing calculator to do this kind of work for us, because it's easy to lose terms somewhere in there, which I'm sure I did, and I'll be honest. So if you can find where the right answer is or where the error is in my algebra, let me know how that goes. Okay, I'll see you Monday, Tuesday, see you tomorrow whenever I see you in class.